The key to this problem is understanding what three-dimensional figure we're actually dealing with. Now, you may have been unfortunately hurt a little bit by previous teachers who might have cheated and called something that looks similar to this a triangular prism. Because yes, it is close to a triangular prism, but if we're really being specific, this edge of what our triangle would be is not an edge, a straight edge at all. It's a curved surface. So really, we got to think about what was the cake originally before we would have gotten our slice of the cake. And it would be a cylinder. It appears with this rounded surface, if we would have the original cake, it'd be a circular cake with sides or a cylinder. So really, this piece of cake is a slice out of a cylinder. So that's going to change our approach from what we would have done if we would have thought this is a triangular prism. Because now we're going to use our knowledge of how to find the surface area and the volume of cylinders, and to then take only a portion of that using the angle measurement we have here. So here's what we're going to do. We're going to first look at the area of the two bases together. And how we do that is we're going to find the area of what would have been the full circle, and then we're going to times it by our angle, the central angle of that circle, divided by 360. And doing that is going to scale down our full circle to just the portion of the circle that we have here. So remember, the area of a circle is pi r squared. So we'll do pi times, in this case, r is 29 squared. And then we're going to times it by 20 divided by 360. Think if we had exactly 1/4 of a circle. That would be like timesing this area of the circle times 90 over 360, which is timesing it by 1/4, which is exactly what we think we would get if we would take only 1/4 of a circle. So we're doing the same thing here. 20 divided by 360 gets our portion of the circle, the area of this portion of the circle, or what we call a sector of the circle specifically. So I'm going to type in my calculator, and now I'll get pi times 29 squared times 20 divided by 360. That will get a grand total of 146.78. But remember, we want to find both the bases together, so we need to times that result by 2, and I get 293.56. Now the lateral surface area, again, is a little trickier than we're maybe used to with some of these problems. Nothing out of your ability level, but takes a little bit of thinking. So how many sides or how many shapes make up the lateral surfaces? Well, it's going to be this rectangle here, the rectangle on the other side of the cake, and this curved surface on the outside of the cake. The rectangle's pretty simple because we know the area of a rectangle is just the length times the width. In this case, it's a radius times the height, or 29 times 13. So I'm going to write 2r for the area of the two rectangles. And 29 times 13 gets me a total of 377. Since we want both rectangles, times by 2 to get 754. So that's one part of the lateral surfaces. And now we need to find this curved surface. So again, we're going to use the same strategy as we used with the area of our base by taking what we would have gotten had we had the whole cylinder and then timesing by 20 divided by 360 to get only the portion that you want. So to find the lateral surface of a full cylinder, what we did, full cylinder, is we took the circumference times the height. Because remember, if we cut open a cylinder and unroll that lateral surface, it's one big rectangle where the top of that rectangle is the circumference and the side is the height. So same idea here. We want to go ahead, and I'm going to do C for curved surface. So we would have done that circumference, which is 2 times pi times r, which is 29 here, times our height, which is 13. That would find the curved surface of the full cylinder. But now to find only the portion we want, all we need to do is times by 20 divided by 360. Again, that gives specifically the portion of the curved surface that we have in this slice as opposed to the full thing. And that total should give me 2 times pi times 29 times 13 times 20 divided by 360. That'll give me 131.60. Now we want to add that result to the area of the rectangles to get all three of those lateral surfaces. And that will give me a grand total of 885.60. So for the total surface area, we want to add the lateral surfaces plus the area of the two bases, and that'll get us 1,179.16. For the volume, same with all of our prisms. It's the area of the base times the height. And we already found the area of the base right up here. And going back in my calculator to when we solved that, the area of the base was 146, or half of this 293 value, because that was both bases. So we'll take the 146.78 times by our height, which is 13, and the volume will be 1,908.17. Let's see if that's correct. It is. So that's what you have to do for this problem, is just remember that it's actually a portion of a cylinder, not a triangular prism, which I think it may look like at first glance, which could confuse some people.